Hi, my name is Pavan, and I'm going to be explaining the basis of our project. What we have is a projectile motion launcher. What it does is it launches a ball at a constant constant initial velocity at the amount of degrees that we angle it to. What we've done is we've angled the projectile launcher at 90-degree intervals from 0 degrees to 90 degrees. And we basically come up with several graphs that represent the data. But what I want to talk to you about is how the velocity on the y-axis and how the velocity on the x-axis differ from one another, and how it influences where the ball will land. From 0 degrees to 45 degrees, the velocity x is greater than the velocity y. That's why it travels farther on the x-axis than it does on the y-axis. At exactly 45 degrees, both the velocity x and the velocity y are the exact same. That's why it'll land at the farthest point, and the distance it travels on the y-axis will be equivalent to the distance it travels on the x-axis. And finally, from 45 degrees to 90 degrees, the velocity on the y-axis will be greater than the velocity on the x-axis. This means the ball will travel higher and it'll go down shorter, so the range will be shorter from 45 degrees to 90 degrees.
So this first graph is the graph with the degrees and the ranges that we tested out. So the degrees are at 9 degrees interval, and these are the corresponding ranges. The reason for the complementary angles are not exact range is mostly because of air resistance. This graph shows the predicted range according to this formula. For V1, for velocity, we calculated the velocity according to the first graph with the data points. And so the x-axis would be sine 2 alpha, and the y-axis will remain range. So as you can see here, the complementary angles should have the exact same range if everything is constant. This graph shows the linearization of the first graph, and where the x-axis is sine 2 alpha, like the previous graph, and the range is we got the range from experimentation.
So the ELA component of our project basically details the process we did to complete our project. It is found on our website, which will be attached in this video link below, but basically it describes what we did each day of our 4-day project. On the first day we asked our teacher to approve our project. On the second day we conducted the actual experimentation. On the third day we did the calculations that resulted in these graphs, and on the fourth day we made all the videos that you can see in this video right now.
The social studies component of our project is with war technology. So, if, for example, missiles and rockets, and see whenever at maximum range would be at 45 degrees, and from 0 degrees to 45 degrees, the ranges would be increasing, and from 45 degrees to 90 degrees, the range would be decreasing.